All right. I hope you guys are having a good Friday. What we're going to do today is we're going to spend a little bit of time getting you ready for your quiz on Tuesday on significant figures. So to just give you a little bit of a refresher, the non-zero numbers, I'm talking 1, 2, 3, 4, 5, 6, 7, 8, and 9. Remember, the non-zero numbers always count as significant. Well, giving up answers here. The leading zeros, the zeros in the front, never count as significant. And then the captive zeros always count as significant. And then the trailing zeros only count if there is a decimal. Okay, so non-zero numbers always count. Zeros in the front never count. Zeros in the middle of two non-zero numbers always count. And the ones at the end count if there's a decimal. So we also talked about multiplying and dividing yesterday with significant figures. So yesterday we talked about if you have a really good measurement up against a really crummy measurement, you have to show that in your data. So let's say I have a 3 sig fig number times a 2 sig fig number. We always pick the one that is the smallest. That is the smallest number of significant figures. So that would give me a 2 sig fig answer. We could have a great number like 6 sig figs against a 2 sig fig number, and I can only have 2 sig figs. If I multiply two numbers of the same accuracy, something with 3 sig figs against something with 3 sig figs, that's going to give me 3 significant figures in my answer. And again, I get a great number, 6 significant figures, but if I multiply it against one that only has 1 significant figure, I only get 1 significant figure in my answer. So that's kind of the refresher of what we had going on. So let's now talk about what we're going to do on our worksheet today. So you're going to take your rules, okay, and we are going to circle the significant figures in each of these estimated measurements. So remember, non-zero numbers always count, captive zeros count, and non-zero numbers count, and numbers at the end count if there is a decimal. So that whole number counts. On this next one over here, leading zeros never count. They are there for a reason. They are placeholders. They show orders of magnitude, but they are not significant measurement numbers. So I really only have the 4, the 1, and the 8. So what you're going to do is you're going to circle up those significant figures and check the key. Then I had some practice with rounding. Okay, so you're going to take these numbers and I want you to round them all to 4 significant figures. So I got 3.682417 is maybe what comes off of my calculator. If I want to round to 4 sig figs, that's 1, 2, 3, 4. So I'm going to round to the after that 2, but that 4 is going to tell that 2 to stay the same. So my final answer, if I had rounded to 4 significant figures, would be 3.682. Be careful on the next one here. I'm trying to be tricky on that one, so good luck. So you're going to round to 2 sig figs. You're going to round to the 2 places after the decimal, all that kind of good stuff. Same thing here. We're going to take the same number. We're going to round it in different amounts. Remember, on this one, the leading zeros don't count. So the first fig that is significant is going to be that 3. So if I wanted to round that number to 1 sig fig, I'm rounding it as 0.003. Okay, so that's kind of the front. The back, you're going to do a couple problems where, remember, we're looking at the weakest measurement to see how we're going to round. So with your calculator, you're going to do like 18.26 times 7.8. And what you're going to get on your calculator is 142.428. And remember, your calculator doesn't care about significant figures. You do. And so what you're going to do with that is you're going to say this first one is a 4 sig fig number, and this one is a 2 sig fig number. So I have to figure out how to round this to a number that would have 2 significant figures, because you always choose the smaller one. So we can get rid of these numbers after the decimal, because I know I'm going to have to only do 2 significant figures. So what number is very close to 142 but can give me 2 significant figures? The mistake is people will cut this off and be like, yep, 14. Whoop, got it. But 14 is just drastically different than 142. So what we're going to do is we are going to pick a number that's really close to 42, but offers 1 significant digit. And so what you're going to do is you're going to say 140, because that gets me my, without a decimal, because that gets me my 2 sig figs, so I can properly answer that. Let's do another one. So we had 10.4 divided by 6, enter. And what you're going to get is 1.7333333, all those numbers. Okay. And now we're going to take a look at our figs. This is a 3 sig fig number, divided, by a 1 sig fig number. And when you do that, you end up needing just 1 sig fig. So how are we going to round? Well, I need to round to just this first number, and I'm not going to cut it and just call it a 1. This 7 is going to do what to the 1 on its way out? It's going to turn it into a 2. Okay. You might have to add figs sometimes to show your accuracy. This is 2 very well measured numbers, 2.00 times 5.00, and your calculator is going to spit out the number 10. However, how many figs do I have here? This is a 3 sig fig number times a 3 sig fig number, so I want 3 sig figs in my answer. 10 does not give me 3 sig figs. Can anybody think of how I could turn 10 into a 3 sig fig number? 10.0. Okay. So what I want you to do is you're going to finish this worksheet front and back. You're going to check the answer key. And then in the last 15 minutes of class, what's going to happen, and they're just going to give you a practice quiz, and you'll get credit for doing it, just to kind of see where we're at before our real quiz, which is coming up on Tuesday. Okay. I hope you guys have a great weekend. Thank you.